The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Firstly, what is titration? Well, as it says here, titration is the technique utilized to determine an unknown molarity of an acid by adding a base of known molarity to a known volume of acid. Here's the basic setup as you see here. You're going to have an unknown concentration of an acid in your Erlenmeyer flask, and then in your burette here, you're going to have a known concentration of base, and from that, you can also, besides the molarity of the acid, right, another thing that you're going to want to calculate is the pH of the solution. And you can use something called a pH meter, as we see here, and you're just going to have to insert this part of the instrument into your Erlenmeyer flask. Furthermore, there's also the neutralization reactions, right, that take place, and you can also use your pH meter. And you could also use the color change in the acid-base indicators, right, that demonstrate the neutralization reactions. Furthermore, the pH meter can also help you put forth titration curves. And the titration curves tell us at the different times what we're going to have is, or intervals you could say, or amounts of base added to our unknown concentration of acid, what that pH is going to be, and then from that you can create a curve, right? And let's just get right into it and take a look at what a titration curve looks like. Here we're looking now at a titration curve of a strong acid and a strong base. In particular, the pH titration curve for 25 milliliters of 0.1 molar hydrochloric acid with 0.1 molar sodium hydroxide. Now, what that's actually telling us is if we go back here we're going to have 25 milliliters in our Erlenmeyer flask, and then we're going to have a 0.1 molar sodium hydroxide base in here, right? That's going to be our base. So you can also call it a titrant. That's going to be our titrant in here. And what's going to end up happening is we're going to add different volumes of the base into here. And from that, we have this beautiful graph, as we see here. Furthermore, at different volumes of NaOH being added, the pH is calculated. And now we'll take a look at how to calculate that pH. Okay, firstly, when we don't add any sodium hydroxide, right? And remember, this is a strong acid and strong base. So when we don't add any sodium hydroxide here, how do we calculate the initial concentration of our hydrochloric acid? Well, we know it's a strong acid, and in the previous acid-base lectures, we demonstrated from the molarity how to get the pH. And if you follow that method, you're going to get 1.00. Wonderful. Now, one other point before we calculate the pH at 20 milliliters that I would like to bring up to you is the equivalence point is when you have equal amounts of your titrant and your acid. Here, what we're going to have is we're going to have 25 milliliters of hydrochloric acid, and we're going to have 25 milliliters of sodium hydroxide. That's going to be the equivalence point, and that's what that is. Now, we'll get there in a moment, but let's now calculate the pH, how to calculate the pH prior to the equivalence point. More specifically, when we have 20 milliliters of sodium hydroxide. Well, what we can do is, let me just do this on the next slide here, is we'll first calculate our moles of We'll first calculate the moles of our strong acid, then we can calculate the moles of our strong base. Depending on how many moles we have left, from there we can calculate the concentration, and from the concentration we can actually find our pH. Let's go ahead and take that route. We just said that in our flask, right? We just said that here we're going to have 25 milliliters, and how do we know that? We just said that right here, right? That we're going to have 25 milliliters of hydrochloric acid, right?